Hey everyone, and welcome back to Engineering Illustrated. Today's top tip will help us find vector components of a vector defined like this super quickly. I call this technique similar triangles. A shape is similar when one shape can become the other after a resize, flip, slide, turn, or combination of those moves. As we leverage this property, more specifically the side-angle-side criterion, we can quickly find both components. There's probably a more mathematically rigorous proof out there, but my goal is just to show you why you can trust this technique and how to do it. So let's get into it. A lot of people, when they see something like this, are tempted to find this angle down here and use that to find the other ones. And so we might as well start there. To do that, we would have cosine of angle theta, we'll call it theta, equals 4 over 5. Solving for theta gives us theta equals cosine inverse of 4 over 5, which, running that through the calculator, gives us 36.87 degrees. So that's one way to do it. Now you have that angle, and you can use that to find your components using another cosine and a sine. But let's see if we can find a shortcut. First, let's recognize that this angle here is also theta. It's the same angle. And so let's do a similar analysis involving the magnitude and the component along the y-axis, Fy. We end up with cosine of theta, it's the same theta, equals our adjacent, which is Fy, over our hypotenuse, which is 1200. So now we might be able to see where we're going with this. These are equal, which means we can set these equal to each other directly, which gives us Fy over 1200 equals 4 over 5. Pretty easy to solve that. For Fy equals 1200 times 4/5. Once again, if we run that through the calculator, we find that Fy equals 960 newtons. So now we can kind of see how it's done. So let's do the Fx vector. We have Fx over that same 1200 equals, this time we're interested in this side and the hypotenuse. So we do 3 over 5, which gives us Fx equals 1200 times 3/5, which comes out to be 720 newtons. So hopefully that was pretty clear. We'll do one more example to see if we can drive it home. So this is a different vector, different magnitude, and the triangle is flipped, as you can see. I'll just show you how quickly we can do this. We can find Fx right away equals the hypotenuse, which is 1000, times, we're in the x direction, so we're interested in this one and this one, 4/5 equals 800 newtons. And Fy similarly is 1000 times 3/5 equals 600 newtons. So there we have our answers. No trig involved other than in the derivation, and we're able to find that quickly without the use of any angles. This will work for any triangle like this. Grab our magnitude and multiply it by the side that we're interested in over the hypotenuse of the similar triangle. And that will give us our component in that direction every time. This is a super useful trick. Hopefully it saves you from trying to memorize the inverse cosine of 4/5 and 3/5. If it's still not making sense, check out the Khan Academy lesson that I've linked in the description to drive it home. Thanks for watching, and check out my other videos for more techniques and example problems. I'll see you next time.